Alrighty, so today we're going to be talking about the angle of elevation. So we have been talking recently about the trigonometric functions, so that is going to be our SOHCAHTOA, okay, sine, cosine, and tangent. Okay, so we are still working with our trigonometric functions, but now we're going to be looking at application-based problems, specifically today, angles of elevation. So the angle of elevation is going to be the angle formed by this horizontal line and the observer's line of sight to an object above the horizontal line. So if this individual is looking straight across at this Eiffel Tower, okay, we create this horizontal line that's parallel to the ground. But as the individual looks up or elevates their line of sight, okay, they create this angle, all right, known as the elevation. That determines the new line of sight. As it gets larger, as they look higher up, the angle gets bigger. Okay, so let's look at some examples. So on our first example, Leah is going on vacation. She wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. So I'm going to go ahead and highlight that because that's probably important. Okay, so the top of the castle is at 38 degrees. She also knows that the castle is 190 feet tall. If Leah is about 5.5 feet tall, how far is she going to be from the castle to the nearest foot? Okay, so we have a few different pieces that we need to add in. Okay, so Leah is over here. All right, Leah is looking at the castle. All right, she's about 5.5 feet tall. Okay, this is definitely not to scale. She knows the castle is 190 feet tall, and we're told that her angle of elevation, the line of sight to the top, is about 38 degrees. Okay, we want to know how far away she is from where she's standing to the castle itself. Okay, so this is going to be the side length that we're solving for. Okay, so let's recreate this as just a triangle so it looks familiar to what we've seen before. All right, we have this right angle created by the castle. Okay, we are looking for the distance from Leah to the castle, but notice here, Leah's 5.5 feet tall, and the castle is 190 feet tall. So, if we're taking into account just the 38-degree angle of elevation, we need to subtract Leah's height from the castle height. Okay, so we're going to say 190 minus 5.5, okay, is equal to 184.5. All right, that is the length created by that 38-degree angle of elevation. Okay, so now we're going to think back to what we've gone over before, those trigonometric ratios. Okay, so we have x, so we need a missing side length. We need to find that missing side length. When we are calculating these, we use our regular functions, so either sine, cosine, SOHCAHTOA. Okay, sine, cosine, or tangent. So we're going to look at where our angle is. Okay, we look opposite to the other side, so 184.5 is opposite, and then x lies along our angle, so x would be adjacent. Okay, so we have opposite and adjacent, which means we will need to use tangent. Okay, so we have the tangent of theta, or our angle, is equal to opposite over adjacent. Right, this is a total of 184.5 over x, because we don't know that x value. Okay, we were given our angle measurement, so all we have to do now is just plug in our information. So the tangent of 38 equals that side ratio. Okay, but remember, we are looking for x, so we need to solve for x. Right. Multiply both sides to get rid of our denominator. Okay, so we have x times the tangent of 38 equaling 184.5. To get x by itself, we have to divide by tangent of 38. Okay, So x equals 184.5 over the tangent of 38. So now all we have to do in our calculator is type in this equation right here, 184 divided by tangent of 38 in that order. So when we type that into our calculator, we are going to get that x equals 236, about 236.1 feet. But remember, we wanted to find it to the nearest foot, so x equals 236. Okay, so Leah is about 236 feet away from the castle. Okay, so our next example, all right, last example for the day, we are playing some football. Okay, so the crossbar of a goalpost is 10 feet high. Okay, the field goal attempt is made 25 yards from the base of the goalpost. And then also the field goal attempt clears the goal by 1 foot. This is going to be important. Okay, so we want to find the smallest angle of elevation at which the ball could have been kicked. Okay, so let's fill in our picture. We have our crossbar, which is 10 feet high. Okay, we were told that the field goal attempt from the base was 25 yards. Okay, so 25 yards. All right, and then we create this path by kicking our ball, and then as we kick the ball, let's draw our little football here. Okay, we clear it by 1 foot. Okay, so little start right here. We are going to add 1 foot because that's how much the ball clears the goalpost. Okay, so if we create this triangle as just a triangle, no pictures, like no other fanciness, okay, we have our 10-foot crossbar height plus the 1 foot clearance of our football, so 11 feet total high, and then our 25-yard attempt distance. Okay, so 25 yards. All right, but before I get started, notice here, 11 feet, 25 yards. We need to have these two units the same. Okay, so if I know that 1 yard equals 3 feet, then I could say that 25 yards is 75 feet. Let's try to keep whole numbers. Okay, so for our purpose of solving, we actually need to use 75 feet for this base. Okay, so again, the last thing we were asked to do is solve the smallest angle of elevation. Okay, so in order to do that, we know we're looking for the angle, so we have to use the inverse. Okay, so remember, inverse is where we have this little negative exponent at the top. It's what helps us solve for the angle measurement when we're given side lengths. Okay, so to know which one we have to use, we're going to say, okay, I have my angle, I have an opposite and an adjacent. Okay, so when I have opposite and adjacent, I know I have to use tangent. So the tangent is equal to opposite over adjacent, or 11 over 75. Okay, this was the information from my triangle. All right, but remember, we're looking for the angle measurement. Okay, so we need to say theta, or our angle, is equal to the inverse tangent of this specific side ratio. Okay, so once we're here, we have our equation set up. You are going to type in tan inverse times 11 over 75. Okay, and when you type that in your calculator, you get that theta, or this angle measurement, is about 8.34. Okay, so remember, we want to the nearest degree, so theta is at least 8 degrees. Oops, that's percent. 8 degrees. Okay, that way we know it would clear. Okay, all right, good luck on your assignment. Let me know if you have any questions.